All right, in this video, we're going to have to look how we're going to classify or group numbers. So first, I want to kind of use an example. Right here, I have a bunch of colored pencils. How can we group these pencils? One way, we can maybe group them by height, okay? Or we can actually group them, let's do a little bit easier and do it by coloring. So if I look at this one here, I can put some of my, my darker colors, my black and my gray together, put a couple of my oranges, group my oranges together, grab a couple of yellows, group my yellows together, get some red, grab my red pencils, a couple of browns, and so I can group them here. I got some blues, some greens, maybe put this in with reds and browns. And now we can kind of get into a debate now. This color here, put it over here with our yellow. So now we kind of get them all grouped together by their colors. And we can get into a big debate now with this one here. This pencil here, is this going to fall into reds or is it going to fall into browns? So we get into a big debate about how we're going to group them, in colors. But what we're going to do is we're going to be grouping our numbers together. And we've got a different method that we use it. So instead of using colored pencils right now, we're going to be using something called real numbers. Now, real numbers are basically numbers found on the number line. So if you looked on this paper down here, the real numbers include both rational and irrational numbers. All real numbers are found on the number line. So that's very important. Any of the number here we can find on the number line. But let's start at the top. So when we classify numbers, think of numbers as balls or little small spheres. If a number can fit through one of these funnels, it will pass through the funnels below. For instance, if you put a ball up in this top funnel, it'll go through this one, through this funnel, and ultimately all the way down through the bottom. Now, if it's too big, it won't fit up here, and too big, it won't fit in here, but it will fit there. It'll go all the way through these. Or if it fits through here, it'll go down through that, through this bottom one here. So that's what we're looking at. So what numbers can fit in the natural? So when we call natural numbers, we call them counting numbers. Look around where you're at. If you're in your room, look at whatever you have lying in your room, and you can start counting things. And we count using 1, 2, 3, 4, 5, 6, 7, 8, 9, and we keep going up. Any number that you use to count, we call that a natural number. Now, when we looked at this example up here, we looked at the example -10. When we count, we don't count by negatives. We don't say, oh, look over there, there's 5 of those, 4 of those, 3 of those, 2 of those, 1, 0, -1, -2. We don't use the negative numbers. So only our counting numbers are our natural numbers. Now here, when we look at whole numbers, the only thing different about natural numbers and whole numbers is the number 0. That's the only difference. So all of our natural numbers will fit through here and will fit into the whole numbers. The only number that goes into the whole that's different than our natural is 0. Integers. Integers are simply all of our negative natural numbers. So I have 1, 2, 3, 4, 5, 6, and I got -1, 2, 3, 4, 5, 6, and -7, and -13, and -500. So those are all of our integers. Rational numbers are numbers that can be written as a fraction, that we see as a fraction, like 3/4 and -8/5. So we have a fraction here, we have an improper fraction, a positive and a negative. Either one of those are rational numbers. Or a number that can be written as a decimal, that it repeats or terminates or ends. So these ones here are a rational number. Or if I have a mixed number that has a fraction in it, that's also a rational number. If I have a number that cannot be written as a fraction, it's irrational. So that happens to be √5, -6, √2, and pi. These are forms of irrational numbers because we cannot write those as fractions or their decimals go on forever. But all of these numbers, all of them are real numbers.